All right, so in order to compare the two data sets between the water temperature between St. Petersburg, Florida and Key West, Florida, we're going to have to compare a couple of different things about the data sets. It wouldn't be enough to just simply compare the means of both of them. To get a really good idea of what's happening, we should really be comparing the mean, median, mode, range, and interquartile ranges to get a better overall depiction of what's happening with our data set. So let's go ahead and use this resource that walks us through finding all of these different values. And we're going to start with St. Petersburg, and then we're also going to go through the example of Key West, Florida.
First, look at the data for St. Petersburg. Arrange the data in order from least to greatest. The mean is the sum of the temperatures divided by the total number of temperatures. Add the temperatures from St. Petersburg. There are 12 water temperatures. So the mean water temperature for St. Petersburg is 75 degrees Fahrenheit.
Something I want to bring up really quickly right here is the fact that the reason that we know that there's 12 is because there's 12 months in a year. So if you added, this is January, February, March, April, all the way through December, obviously we know there's 12. And if we added up all of our data values for St. Petersburg, we would get 900. So 900 divided by 12 gives us 75, which is the average water temperature in St. Petersburg, Florida.
The mode is the most frequently occurring value. The modes are 64, 84, and 86, each occurring twice. Now find the minimum and maximum.
Before we move on to the minimum and maximum, I just want to bring up that it is okay to have no mode for a data set. Maybe nothing happens more frequently than another. It's okay to have just a single mode. It's okay to have more than one mode. Sometimes if we have two, we call it a bimodal data set. Sometimes this one's technically a trimodal, but oftentimes we actually just call it multimodal data set. And it just kind of gives us a better idea of what are the most frequent temperatures in this particular data set. When we discussed mean, median, and mode before the break, we had a few data sets that had no mode and a few data sets that had one or two, just one single mode or bimodal. Now the minimum and maximum are going to be exactly what you think they are. The minimum temperature of the data set and the maximum temperature, the highest temperature of water in St. Petersburg.
The minimum is 62. And the maximum is 86. The range is the difference of the maximum and minimum values.
It's always
so the
going
range
to be
is 86 minus 62.
It's always going to be the maximum value minus the minimum value.
Or 24. Now find the median.
So what's happening right now is we just grabbed the data set and rewrote it. And you'll observe that they started with just the whole data set and are starting to gray out from the outside in, kind of like canceling out 62 and canceling out 86, 64 and 86, 64 and 84. And they're going closer and closer to find the center of the data set. Since this data set is even, we should have two numbers in the center that we will have to take the mean value of.
For a data set with an even number of data values, the median is the mean of the two middle values. So the median is 76.
And how we got 76 is we took 74 plus 78, and that gave us 152. 152 divided by 2 is 76. Something else super important to note is the median will always divide your data set completely in half. Whatever is on the left-hand side of the median must, however many data values are on the left-hand side of the median, must also be on the right-hand side of the median. So notice if I have 2 values as my median, I have 1, 2, 3, 4, 5 data values on the left, and 1, 2, 3, 4, 5 data values on the right. My median will always split my data set 50-50. It will never be uneven. If it is uneven, it would not be the true median. So, for example, this data set has 12 values, right? Because there's 12 months in a year. And some of you might think initially, oh, well, the number between halfway between 12 is 6. But if I were to count the sixth value in this data set, 62 being 1, 64 being 2, 3, 4, 5, 6, the 64th data value is 74, and that leaves me 5 values on the left, but 1, 2, 3, 4, 5, 6 on the right. That is not truly the median, which is why I had to take the average of the two values of 74 and 78.
The first quartile is the median of the lower half of the data. The median of the lower part is 66. The third quartile is the median of the upper half of the data. The median of the upper part is 84.
So we found those medians in the same exact way, right? There was 1, 2, 3, 4, 5, 6 values because 76 is technically in between. So I needed to find the median of that lower part. So I needed these two values here. So I left 62, 64, 70, and 74 on the lower half of my data set, right? 76 is right in between 74 and 78. That's my median. So I'm taking the median of this half of my data set. So I did 64 plus 68 divided by 2 gave me 66. Similarly, we did the same on the right-hand side. Anything to the left of the median is considered the lower half of the data set, and anything to the right is considered the upper part of our data set.
To find the interquartile range, subtract the first quartile from the third quartile. So the interquartile range is 18.
Something to note also is the interquartile range will always be Q3 minus Q1. And because we organized our data set from smallest to largest, Q3 will always be the larger value. So we should never get a negative number for an interquartile range. So now that we've completely done that from St. Petersburg, let's do the exact same process for Key West so that we can actually compare our data sets.
Now look at the data for Key West. Arrange the data in order from least to greatest. First, find the mean. So the mean water temperature for Key West is about 79 1/10 degrees Fahrenheit.
I would just say 79.1 degrees.
Next, find the mode.
82 is popping up twice, as is 87.
The modes are 82 and 87, each occurring twice. Then find the minimum and maximum. The minimum is 69, and the maximum is 87. Now find the range. The range is 87 minus 69, or 18. Find the median.
Again, it will be the average of the two middle values.
The median is 80. Then
And take
find
the
the
median.
first quartile.
Find the first quartile by taking the median of the lower half of the data set. And similarly, find the Q3 by taking the median of the upper half of the data set.
The median of the lower part is 73 and 5/10. Now find the third quartile. The median of the upper part is 85 and 5/10. Finally, find the interquartile range.
So 85.5 minus 73.5 is going to give us an IQR of
The
12.
interquartile range is 12.
Alrighty, so here's the data that we've compiled for Key West and also St. Petersburg. St. Petersburg being the first data set that we compiled, and Key West being the second data set that we compiled.
The range and the interquartile range show the temperatures varying less at Key West than at St. Petersburg. Also, the temperatures at Key West are generally higher.
So something really interesting to think about is if we were to only look at the mean of the values, sure, we would get the same inference that St. Petersburg, since the average temperature is 75 degrees, and since Key West average tends to be 79.1 degrees, we could infer that Key West has typically warmer water temperatures. However, it doesn't give us a very good idea or very solid understanding of the data. So us comparing the modes also shows us that the most frequently occurring temperatures are higher in Key West than they are in St. Petersburg. Notice St. Petersburg has a mode of 64, which is significantly lower than any data values that we had in Key West. Also, if we compared the minimum and maximum values, the minimum was higher in Key West than it was in St. Petersburg, and similarly, the maximum was a little bit higher as well. Something that actually tells us a lot of information that doesn't seem to at first is the range. The range is 24, so that means there's a difference of 24 between the maximum value and the minimum value. So 24 degrees is how much the water temperature ranges. Since the range is smaller, since 18 is smaller than the number 24, that also tells us that the temperature stays fairly close to the average values. So the difference between 87 and 69 has a smaller range, which means it's going to tend to be a little bit warmer than the temperatures at St. Petersburg. Our interquartile range also gives us a very similar result. But overall, if we had just looked at one or two of the elements, we wouldn't get as well-rounded of information about the temperatures from Key West. So that's why it's really good to not just look at one particular measure of central tendency, but to take a collective look at all of the various measures of central tendency to really get a good idea in order for us to make valid inferences based on the information that we have presented.